Hi, in this video, we're going to take a look at basic DHCP v4 configuration. Okay, so we're going to be looking at this from configuring DHCP as a server on a Cisco IOS router. But as far as the router's role, so it can act as a DHCP v4 or even a v6 router. V6 is in another video. Can also be a DHCP client, so it can actually be requesting an address on its interface. That's usually for like branch offices and things like that. Not super common as far as in an enterprise network, but well, I shouldn't say super common, but it's there's definitely situations where we just have our client routers in branch offices receive their IPv4 address information dynamically from the enterprise. Okay, anyway, also the router could act as a relay agent. We talk about that in another video, but that's when the DHCP server resides on a network apart from the DHCP v4 client. Okay, so the first thing that we're going to do, so here we have router R1 acting as a DHCP v4 server. Okay, so we're going to actually configure R1 to act as a DHCP v4 server. We'll see it for both the 10.192.168.10.0 network and the 192.168.11.0 network. But there's certain addresses that we do not want to have it allocate or assign to addresses, so a certain range of addresses. So we're going to exclude those addresses, and we use the IP DHCP excluded address command for that. For example, in the 10.0 network, if we wanted to make sure that we exclude the addresses in the range 192.168.10.1 through 192.168.10.9 and 192.168.10.254, that means that the addresses assigned to the 10.0 network here will start at .10 and end at .253. Okay, the next thing we're going to do is create a DHCP address pool. So in global configuration mode, we just say IP DHCP pool and given it a pool name, and you'll see that takes us into DHCP v4 configuration mode. And from there, in DHCP configuration mode, this is where we define the network address. Well, really, it's just the network address of that interface. And we'll see an example of that in a moment. We also define the default gateway address, and that's something done only in DHCP for IPv4. DHCP for IPv6, devices can only receive their default gateway address automatically from the router advertisement. Okay, we can also assign the DNS server address, domain name, lease time of the DHCP lease, and any other kinds of optional codes. Okay, and if we did a question mark, you can see all the ones, and those are the ones that we're going to focus on, mostly things like network, DNS server, domain name, and etc. Okay, let's take a look at an example. So let's do it for the 192.168.10.0 network. Okay, we're going to exclude those first 9 addresses and the last address. So let's go ahead and do that. Awesome. Okay, we create the LAN pool 10. And I do uppercase anytime these are variables, I like to call them, or words, names, but things that I'm naming, so we don't get that confused with a command or a parameter. Okay, so next we assign the network address. So this says any device in our 192.168.10.0/24 network requesting an IPv4 addressing information via DHCP will be assigned one automatically. So it's acting as a DHCP v4 server for that local area network. Okay, we assign the default gateway, and we can also do a domain name. Okay, so we can verify the information using some different show commands like show IP DHCP server statistics and DHCP binding, and if there's any conflicts, the DHCP conflict, and we can show complete information about that pool using the DHCP pool command, all show IP, prefacing those other parameters. The IP is what specifies IPv4. We'll see some examples. Okay, here we see show IP DHCP binding before PC1 boots up. After PC1 boots up, we've assigned it the first address. There's the client's MAC address, release time, and it received the information automatically. Okay. So before and after PC1 boots up, if we did show IP DHCP server statistics, you can see after PC1 boots up, these are the messages, discover messages, request messages, offer, acts. We have one binding. Okay, on PC1, we can actually see that now it has received that information. Here's its IP address, v4 address, subnet mask, default gateway. This was the server that gave the address, and here's the lease time information. Okay, we can do the same thing for the 11.0 network. Okay, here we're just going to exclude the first 9 addresses and also the last address. We'll call it LAN pool 11. And here, notice we used the network command 192.168.11.0 with 255.255.255.0 as the mask. So any devices on this interface, on the Fast Ethernet 01 interface, will receive any DHCP clients that will act as a DHCP server for that interface. Okay, default router. So again, of course, a different default gateway address and same domain name. Okay. So after PC2 boots, we can actually see that it has received an address. When we do the show IP DHCP binding, here's our statistics, show IP DHCP server statistics. So we have 2 bindings now, more DHCP v4 messages being shown. Okay. Here's the show IP DHCP pool, and it shows information for both the LAN pool 10 and LAN pool 11. Including number of leased addresses, the address range, how many have been leased. We can configure the router as a DHCP client. We just simply do IP address DHCP instead of configuring it a static address. Okay. And then when we do a no shutdown on the interface, it acts just like a DHCP v4 client. You can see that it has actually received an IPv4 address. All right, so that's the basic DHCP v4 configuration. Not much to it.